Good morning, everybody. Welcome to another installment in Missing Deck Brassica series. This is a very easy set of Sudoku puzzles, at least according to those setters. This one is called Cooking Cabbage, and per the rule description, it says standard Sudoku rules apply. Digits 1 through 9 appear in every row, column, and box, and then thermometers, where digits on thermals are strictly increasing from the bulb, which is a gray circle like that thing, to the tip along the gray line. So if I move my cursor to the top left, row 1, column 1, is the lowest digit, and then row 1, column 2 will increase, row 1, column 3 will be bigger than that one, and so on and so forth along the line. So, this is a 1, 2, 3, 4, 5, 6, 7 cell thermometer in box 1. What that means is, think about it, if this digit was 9, then 8, 7, 6, 5, 4, 3, right? So, this first digit can't be higher than 3. If it was a 4, you'd run out of digits. On the other hand, let's say that digit was lower than 7. Then you have 6, 5, 4, 3, 2, 1. But if this was 6, you'd have 5, 4, 3, 2, 1, 0, and that's not a valid digit. So this digit cannot be lower than 7. This one can't be higher than 3. So that means I've got 3 degrees of freedom on every one of those cells. This is 6 or 8 because it can't be 7, and actually this cell cannot be 9. So that ends up being 7 or 8. Now if this was 8, this couldn't be 7. But it wasn't 7 anyway. This is 8, 6, 5, right? I mean, look at the digit distribution. If this was 8, this would have to be 6, and this is 5. If this is 7, you still have 6, 5. So that cannot be 5. Either way, it must be 5, and therefore I can propagate this down. 1, 2, 3, 4, like that. This is 6, 8. But not 3, it's 6, 8, 9, it can't be 7, and this one ends up as 6, 7, 8, 9. See, I'm going to have the same concern here, except there's 3 cells open. This one, because it crosses a region, I can't do much with. Same with that one, and that one, and that one. So I have to start here. This, again, 6, if that was 6, 7, 8, 9, 10, then you've run out of digits. And this can't be 3, 4, 5, so 1, 2, but it can't be 1, so this has to be a 2, this has to increase. Six, 5, 6, 7, 6, this is actually 3 degrees of freedom, not 2. And 7, well, this is 8, 9. Okay, that gives me a 6, 8, 9 triple in column 2. I don't quite have, well, actually, because these are filled and 7 can't go there, it must go here in column 3, and therefore that rules that out from being 7. So what that means is if this was 9 or 8, this couldn't be 8. Actually, if this was 9, this had to be 8. If this was 8, this is 6. But we don't know anything. 9, 8, 6 is still possible. That way, or 8, 6, 5 is still possible, which would force 4, 3 here. 2, 3, 4, 5 is going to leave 1, 6, 7, 8, 9, but I'm not sure I want to fill, do I? This is 1, 6, 8, 9, because none of those can be 7. That's not 8. there's something going on with that. Am I going to have to do every single thermometer first? I don't like doing that way, but that's a 7-cell thermometer. And this obviously can't be 7, so 8. Well, this thermometer is a 7-cell thermometer, but it can't be 7 or 8. It must be 9. You notice if it's 6, then you're going to run out of digits. So that has to be 9. This can't be 9 or 7. That is 6. So 5, and then actually 4, 5, 3, 4, 2, 3, 1, 2. Yep, I was right. 4, 3, 2, 1. It has to go that way. Okay, so 6 and 9 are rolled out of that one. Let's see, I'm making a mess of this. 1, 2, 3, 4, 5, 6, 7. This is another 7-cell thermometer. But that cell there, which is the very tip, row 4, column 4, can't be 8 or 9. It sees both those digits, so it must be 7, and therefore I can propagate it all the way the rest of the way. Down, as it were. Okay, that means row 4 has 4 through 8. I need 1, 2, 3, and 9. That can't be 1. This isn't 2, and this can't be 2. I think it's 1. Oh, it can't be 1, 2. Oh, it sees 1, 2, and 9, so that must be 3. Therefore, that's a 2, because this can't be 3. 1, 9 makes that cell an 8. 1, 9 is going to make this a 6. But 1, 9 here means this is 3, 4, 5. That fills out box 4. Let's see, this cell cannot be 3, 4, 5, 6, or 9. Well, it can't be 7 either, because then 7, 8, 9, 10. So this, it can't be 6, 5, 4, 3. This is 1, 2. Only. And this cell sees 5 through 9 inclusive. So it's forced to be 3 or 4. That one, I don't think we know much about it yet. This one, because it's a 5-cell thermometer, but it can't be 8, 9. 4, 1, 2, 3. Okay. 4, 5, 6. This is 3, 4, 5. Like that. Well, this can't be 3 or 4, so it must be 2. Remember, it can't be 6. 6, because then 7, and then you run out of digits here. So 2, 3, 4, but it sees 2 of those digits, so that's a 2. That's a 1, which tells me that's a 1. 3, 4 is going to place the only remaining digit that I haven't filled in yet in row 5, which is a 2. 1, 2, 3, 7, 9. That leaves 4, 5, 6, and 8. For column 4, that's 4, 8 only. So is this, and annoyingly, so is that. Okay. I don't know enough about these yet. I wish I did. 1, 2, 3, 4, 9 is going to leave 5, 6, 7, 8. Well, this sees 5, and this is 7, 8, isn't it? It's candidate cells, because it sees 1, 2, 3, 4, 5, 9, and 6. So 7 and 8 makes that cell 6. Let's see, 9 is here in row 2, which puts it here in row 1. this ends up as 5, 7, 8, and this can't be 5. Well, that's 6, 7, so this is 8, 9. See, I end up in that configuration for column 6. See, this cell has to be 6 through 9. It can't be anything lower than 6. These cells also have to be 6 through 9. But that's 1, 2, 7. And this sees 1 and 2. That must be 7. And this sees a 1, so that places 2 and 1 to fill out box 6. Well, this is 3, 4, 8, 9, except it definitely can't be 3 because this one must be 3, so that has to be 4. 8, 9, which forces out 4, 8, 9 here, and that tells me this is a 3 in the central cell of this grid. Let's see, that's not 4 anymore. 5, 6 propagates up in column 1. 5, 6 is going to make this cell an 8 at the very bottom left of this grid. 7, 1. This has to be 3, 4 also. But it sees the 3, so that will indeed do the rest of the leftmost 3 columns. See, 5, 6 in row 8 means that's not 6 anymore. 1, 3, 4, 5, 6, so 2, 7, 8, 9. Well, this sees 2 and 8. This would be 8, 9. And do some other cleanup. Like this, these aren't 8. 5, 6, 7 means these aren't 6 or 7. So this is 4, 8, 9, and this the top corner of box 3 sees the 8, 9. That must be 4, so guess what? That's 8, 9. So I've now got an 8, 9 pair in column 8. That leaves 4 and 5 to place. And that cell, row 2, column 8, sees the 4. It must be 5. So this is 6, 7. And amazingly, I don't know that yet. Let's see. I think this cell has to be 3 because, yep, 5, 6, 7. Triple in column 7, also by rules of thermometers. If that was 5, then 6, 7, and I've run out of digits. And I'd have to place a duplicate, and we can't have that, now can we? 5, 6 in row 8, along with 7, 8, 9, we'll place the 2 in the row. It's in the 1 space it can be. This has to be 5 or 6 at the very bottom right, but it sees 5 in column 9, and that should propagate and allow me to finish this off. And I think all the thermometers will work, although I'd managed to fill out enough sudoku digits that, well, actually, eight, 9, so this is 7. And this is 4 and 9. Well, guess what? These, yeah, I will actually have to use thermometers to fill out this last bit. 3, 4, 9, well, that digit has to be higher than that one, so guess what? 9 and 4 go in the order specifically. That's 6, this is 9, 8, 4, and now I'm just filling things in. And 14 minutes for something that probably should have taken me a bit shorter. You know, if I thought about the thermometer logic more and organized myself solely on that to begin with, I probably would have done this a bit faster. But I appreciate the fact you had to use 7-cell thermometers, and you had to use the thermometer rules on every single one of them. And even though I got classic Sudoku most of the way, the thermometer in column 5, rows 6 and 7, I still had to use that rule to sort out the remaining pair, which unlocked the rest of the puzzle. So if any of you guys try and solve this, let me know how you did.